Good morning students, welcome back to saradamathschannel. Now this is the continuation video of the hyperbola most IMP questions. Okay, let us start the problems. The first problem, if e comma even are the eccentricities of a hyperbola and its conjugate hyperbola, then prove that 1 by e square plus 1 by e1 square is equals to 1. Very easy question and very important question. Okay, what is a given data? E comma even are the eccentricities of the hyperbola and conjugate hyperbola. That is given that E is the eccentricity of the hyperbola and E1 is the eccentricity of the conjugate hyperbola. Okay. Now we have to show that these two values. Simply taking the values of the E comma E1 and substituting the two values in this result LHS to get the answer. Okay. Okay, let us start the solution. So first I take the equation of the hyperbola. What is the equation of the hyperbola in standard form? I am taking the hyperbola equation standard form here. So equation of the hyperbola is, what is the equation? X square by a square minus y square by b square is equal to 1. Okay. And what is its eccentricity? Eccentricity to this one is equals to, eccentricity to this hyperbola is E is equals to, what is the eccentricity formula? Square root of a square plus b square by a square. Okay. Now I am writing the its conjugate hyperbola, which implies its conjugate hyperbola is conjugate hyperbola of this one. Its conjugate hyperbola is, what is the answer? At the RHS you have to take the minus sign, that is x square by a square minus y square by b square is equals to minus 1. Okay. Now what is given? E1 is the eccentricity to this one, that is, which implies eccentricity to this hyperbola E1 is equals to, eccentricity E1 is equals to, so what is the formula of the eccentricity of the conjugate hyperbola? Square root of b square plus a square by b square. Okay. Simply first here I am taking the values of the E and E1. Now replacing the two values in the LHS. So what is the LHS here? 1 by e square plus 1 by e1 square. Okay. So this is 1 by e value square root of a square plus b square by a square. Okay. Whole square plus 1 by square root of b square plus a square by b square. Just simply substituting the values of the e comma e1 here. And this is 1 by, now here squares and square roots are cancelled, so the remaining values are 1 by a square plus b square by a square plus 1 by b square plus a square by b square. Okay. And this is equals to a square by a square plus b square plus b square by a square plus b square. And this is equals to a square plus b square by a square plus b square is equals to 1. The two terms are cancelled here. So this is equals to 1 and that is RHS. Okay. Therefore the result is 1 by e square plus 1 by e1 square is equal to 1. That's all. This is the answer. Okay. Okay, so the next problem. If the eccentricity of the hyperbola is 5 by 4, then find the eccentricity of its conjugate hyperbola. Okay, very easy question but very important. What is given here? Eccentricity of the hyperbola is equals to 5 by 4. Now we want the eccentricity of the conjugate hyperbola. So what is the relation between the eccentricity of the hyperbola and eccentricity of its conjugate hyperbola? Already here I deduced one formula. So what is that formula? 1 by e square plus 1 by e1 square is equals to 1. What is E here? Eccentricity of the hyperbola. And what is E1 here? Eccentricity of the conjugate hyperbola. That is, simply when we substitute the E value here, then you will get the E1 value. That is, simply by applying this formula directly you can get the eccentricity of the conjugate hyperbola. Okay, let us start the solution. So first I am writing the value here. Given that eccentricity of a hyperbola is equals to 5 by 4 and I am taking that this is equals to E, that is given that eccentricity of a hyperbola E is equals to 5 by 4. Eccentricity of hyperbola is nothing but small e here. And I am taking the eccentricity of the conjugate hyperbola be even. Let eccentricity of, we have to find this value now. Conjugate hyperbola is eccentricity of conjugate hyperbola be even. Now I am writing the relation between these two. We know that already here in the before problem we proved this result. 1 by e square plus 1 by e1 square is equals to 1. Now I am substituting the e value here. E is equal to 5 by 4. 1 by 5 by 4 whole square plus 1 by e1 square is equals to 1. That is 1 by 25 by 16 plus 1 by e1 square is equals to 1. That is 1 by 25 by 16 is equals to 16 by 25. 16 by 25 plus 1 by e1 square is equals to 1. That is 1 by e1 square is equals to 1 minus 16 by 25. After doing the LCM, we get that this is 25 minus 16 is equal to 9 by 25. So 1 by e1 square is equals to 9 by 25 means e1 square is equal to 25 by 9. Just reverse this fraction here. So the value of the e1 square is equals to 5 by 3 whole square, which implies the value of the e1 is equal to 5 by 3. Therefore, the eccentricity of the conjugate hyperbola is equals to e1 is equal to 5 by 3. Okay. Therefore, the eccentricity of conjugate hyperbola. The most important to math questions. These two sums are very, very important sums. E1 is equal to 5 by 3. That's all. This is the answer. Understand all of you? Okay, so the next definition, define rectangular hyperbola and what is the eccentricity of the rectangular hyperbola. This is the very, very important to math question, the most important frequently repeating question. So what is the definition here? Rectangular hyperbola. What is the rectangular hyperbola? And find the eccentricity to that one. So a rectangular hyperbola definition. In a hyperbola, x square by y square is x square by a square minus y square by b square is equal to 1. So first here I am taking the standard form equation. If length of the transverse axis is equals to the length of the conjugate axis. Length of the transverse axis is equals to length of the conjugate axis, then that hyperbola is said to be the rectangular hyperbola. Okay. This is the most important definition. If the length of the transverse axis is equals to length of the conjugate axis, then that hyperbola is said to be the rectangular hyperbola. Okay, this is the definition of the rectangular hyperbola. So what is the length of the transverse axis? Length of the conjugate axis. Therefore, that means length of the transverse axis is equal to 2a and length of the conjugate axis is equal to 2b. So 2a is equal to 2b means the value becomes here a is equals to b. Okay. Now what is the equation of the rectangular hyperbola? Equation of rectangular hyperbola means simply we are substituting that a is equals to b in the hyperbola equation. Okay. What is the definition of the rectangular hyperbola? A is equals to b. So finding the equation of the hyperbola, that is, in the hyperbola equation, I am substituting that the value of the b is also equals to a. That is, x square by a square minus y square by b square is y square by a square is equal to 1. So the answer is, the equation of the rectangular hyperbola is x square minus y square is equal to a square. Okay. Now what is the eccentricity? So first I am taking the eccentricity of the hyperbola. What is the eccentricity of the hyperbola to the standard form? What is the formula? E is equal to square root of a square plus b square by a square. But what I am saying here, in the rectangular hyperbola, a is equals to b. That is, I am replacing that A is equals to B in this answer, in this eccentricity. So again I am substituting that B is equal to A here. So this becomes 2A square by A square, that is equals to root 2. That is, when we take A is equals to B, then what we get? The eccentricity value root 2. So this is nothing but the eccentricity of the rectangular hyperbola. That value is equal to root 2. Therefore, eccentricity of rectangular hyperbola is equals to, what is the answer? Root 2. That's all. This is the answer. The most important 2 marks question. Okay.